Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on trigonometry, degree level, chapter Hyperbolic Functions, lecture number 6, in which I will solve some more problems on hyperbolic functions. Now we solve a problem. Problem is if tan alpha plus I beta equal to I, alpha and beta being real, then alpha is indeterminate and beta is infinite. Now we prove this. Given that tan alpha plus I beta equal to I. This is number 1. Taking conjugate of both sides, we get tan alpha minus I beta equal to minus I. This is number 2. Now tan 2 alpha equal to tan alpha plus I beta plus alpha minus I beta. This is equal to tan alpha plus I beta plus tan alpha minus I beta tan A plus B equal to tan A plus tan B by 1 minus tan A into tan B by 1 minus tan alpha plus I beta multiply tan alpha minus I beta. This tan alpha plus I beta is I, tan alpha minus I beta is minus I, 1 minus tan alpha plus I beta is I, tan alpha minus I beta is minus I. Using 1 and 2. And this is equal to 0 by 1 plus I square, minus minus plus and I square. This is equal to 0 by 1, I square is minus 1. This is 0 by 0. Here 0 by 0 is indeterminate. Proved. Implies that tan 2 alpha is indeterminate, then alpha is indeterminate. Therefore, first part proved. Now, tan 2 I beta equal to tan alpha plus I beta minus alpha minus I beta, tan A minus B equal to tan A minus tan B by 1 plus tan A into tan B equal to tan alpha plus I beta minus tan alpha minus I beta by 1 plus tan alpha plus I beta multiply 10 alpha minus I beta. 10 alpha plus I beta is I. 10 alpha minus I beta is minus I. 1 plus I multiply minus I equal to I minus minus plus I by 1 minus I square. This is 2I by 1 minus I square is minus 1. 2I by 1 plus 1 equal to 2I by 2 equal to I. This is number 3. Implies that 10 2I beta equal to I, and 10 2I beta is I 10 hyperbolic 2 beta equal to I. Implies that 10 hyperbolic 2 beta equal to 1. I cancel. Implies that 10 hyperbolic 2 beta is e to the power 2 beta minus e to the power minus 2 beta by e to the power 2 beta plus e to the power minus 2 beta, and this is equal to 1 using componendo and dividendo. That means we firstly add denominator with numerator and then we subtract numerator from denominator. E to the power 2 beta minus e to the power minus 2 beta plus e to the power 2 beta plus e to the power minus 2 beta by e to the power 2 beta plus e to the power minus 2 beta. This is denominator minus numerator. E to the power 2 beta minus e to the power minus 2 beta. And right side, here 1 means 1 by 1. 1 plus 1 by 1 minus 1 implies that 2 e to the power 2 beta by 2 e to the power minus 2 beta. This is 2 by 0 implies that 2 cancel, e to the power, we take this minus means e to the power 2 beta minus minus 2 beta equal to 2 by 0 is infinity, implies that e to the power 2 beta plus 2 beta equal to infinity, implies that e to the power 4 beta equal to infinity, implies that beta equal to infinity. Second part proved. Now we solve the next problem. Next problem is if 10 theta plus I phi equal to cos alpha plus I sin alpha, then prove that A theta equal to n pi by 2 plus pi by 4. B number phi equal to half log 10 pi by 4 plus alpha by 2. Now we Solve this. Given that tan theta plus I phi equal to cos alpha plus I sin alpha. This is number one. Taking conjugate in both sides, we get tan theta minus I phi, and in this side cos alpha minus I sin alpha. This is number two. Since tan 2 theta equal to tan theta plus I phi plus theta minus I phi. This is tan A plus B. Tan A plus B means tan A plus tan B by 1 minus tan A into tan B. Now we use this formula. Tan theta plus I phi plus tan theta minus I phi by 1 minus tan theta plus I phi multiply tan theta minus I phi. This is equal to tan theta plus I phi is cos alpha plus I sin alpha. Cos alpha plus I sin alpha plus tan theta minus I phi cos alpha minus I sin alpha. Using 1 and 2. This is 1 minus. This is cos alpha plus I sin alpha. Multiply cos alpha minus I sin alpha. Using 1 and 2. This is equal to, here cos alpha, here plus I sin alpha minus I sin alpha cancel, 2 cos alpha by 1 minus, this means cos square alpha plus sin square alpha. This is equal to 2 cos alpha by 1 minus 1. This is 2 cos alpha by 0. This is infinity. Implies that tan 2 theta equal to infinity means tan pi by 2. Now general value will be 2 theta equal to n pi plus pi by 2. Since tan theta equal to tan alpha, then general value of theta is n pi plus alpha. Implies that theta equal to n pi by 2 plus pi by 4. N belongs to Z, means set of integers. Therefore, first part proved. Now 10 to I phi equal to 10 theta plus I phi minus theta minus I phi implies that 10 to I phi equal to 10a minus b is 10a minus 10b by 1 plus 10a into 10b. This is 10 theta plus I phi minus 10 theta minus I phi by 1 plus 10 theta plus I phi multiply 10 theta minus I phi. Here using 1 and 2, 10 theta plus I phi is cos alpha plus I sin alpha minus cos alpha minus I sin alpha by 1 plus cos alpha plus I sin alpha multiply cos alpha minus I sin alpha. This is equal to, here cos alpha plus, here cos alpha minus, cancel. So remains 2I sin alpha by 1 plus, this is cos square alpha plus sin square alpha. This is equal to 2I sin alpha by 1 plus 1. This is equal to 2I sin alpha by 2. This is equal to I sin alpha. Implies that left side is 10 to I phi, means I 10 hyperbolic 2 phi, and right side is I sin alpha. Implies that 10 hyperbolic 2 phi equal to sin alpha. I cancel. Implies that this is equal to e to the power 2 phi minus e to the power minus 2 phi by e to the power 2 phi plus e to the power minus 2 phi. This is equal to sin alpha. Applying componendo and dividendo in both sides, we get e to the power 2 phi minus e to the power minus 2 phi. This is numerator plus denominator e to the power 2 phi plus e to the power minus 2 phi. Here e to the power 2 phi plus e to the power minus 2 phi, denominator minus numerator e to the power 2 phi minus e to the power minus 2 phi. Here we have denominator 1. So 1 plus sin alpha, 1 minus sin alpha. implies that this is 2e to the power 2 phi by 2e to the power minus 2 phi, and this is equal to cos square alpha by 2 plus sin square alpha by 2. 1 means this, and sin alpha means sin, we apply the formula sin 2a, 2 sin alpha by 2 cos alpha by 2. Here also similarly we write 1 means cos square alpha by 2 plus sin square alpha by 2 minus 2 sin alpha by 2 cos alpha by 2, and left side 2 cancel, e to the power 4 phi, same base, so subtract power. This is equal to cos alpha by 2 plus sin alpha by 2 whole square, and here cos alpha by 2 minus sin alpha by 2 whole square implies that we take square root both sides, left side e to the power 2 phi, right side cos alpha by 2 plus sin alpha by 2 by cos alpha by 2 minus sin alpha by 2 implies that e to the power 2 phi equal to dividing numerator and denominator by cos alpha by 2, cos alpha by 2 plus sin alpha by 2 by cos alpha by 2 by cos alpha by 2 minus sin alpha by 2 by cos alpha by 2. Here we write e to the power 2 phi equal to, this is equal to 1 plus 10 alpha by 2 by 1 minus 10 alpha by 2, and this equal to 10 pi by 4. 10 pi by 4 means 1 plus 10 alpha by 2, 1 minus, here we have 1, let 1 means 10 pi by 4 multiply 10 alpha by 2, and this is equal to 10 pi by 4 plus alpha by 2, 10a plus b, 10a plus 10b, 1 minus 10a into 10b implies that 2 phi equal to log base e 10 pi by 4 plus alpha by 2. Implies that phi equal to half log base e 10 pi by 4 plus alpha by 2. Second part proved. Now we solve the next problem. Next problem is if tan theta plus I phi equal to tan alpha plus I sec alpha, then prove that e to the power 2 phi equal to plus minus cot alpha by 2 and 2 theta equal to n pi plus pi by 2 plus alpha. Now we prove this. given that tan theta plus I phi equal to tan alpha plus I sec alpha, taking conjugate in both sides, we get tan theta minus I phi, here in place of plus, here minus, here also in place of plus, minus. Now tan 2 theta equal to, here 2 theta means theta plus I phi plus theta minus I phi. Here tan A plus B, formula is tan A plus tan B by 1 minus tan A multiply tan B, and here we have used this formula, and this means here tan alpha plus I sec alpha, and this means tan alpha minus sec alpha. Here we have I, here plus I sec alpha minus sec alpha cancel, so remains only 2 tan alpha. Here tan alpha plus I sec alpha multiply tan alpha minus I sec alpha is tan square alpha plus sec square alpha. Here 1 means sec square alpha minus tan square alpha, this value is 1, and we write this value, and in numerator we get 2 tan alpha, in denominator we get minus 2 tan square alpha. Tan alpha 1 tan alpha cancel, so remains minus 1 by tan alpha, and 1 by tan alpha is cot alpha, minus cot alpha may be written as tan pi by 2 plus alpha. Here general formula, tan 2 theta equal to tan pi by 2 plus alpha means 2 theta equal to n pi plus pi by 2 plus alpha. N belongs to Z, integer, set of integers. Therefore, second part proved. Now, tan I 2 phi, value of this is theta plus I phi minus theta minus I phi. Here tan A minus B, we use the formula and we get this. In place of tan theta plus I phi, we write tan alpha plus I sec alpha, and in place of tan theta minus I phi, we write tan alpha minus I sec alpha, and we get lastly 2I sec alpha by 1 plus, this means tan square alpha plus sec square alpha. In place of 1, we write sec square alpha minus tan square alpha, value of this is 1, and this remains same, implies that tan I 2 phi left side and right side is 2I sec alpha. Here tan square alpha minus tan square alpha plus cancel, so remains 2 sec square alpha. Here 2 cancel, 1 sec alpha cancel, so remains I 1 by sec alpha, and 1 by sec alpha is cos alpha. Left side may be written as tan I 2 phi is a I tan hyperbolic 2 phi, and here I cos alpha, I cancel. Here tan hyperbolic 2 phi equal to cos alpha. Since tan hyperbolic 2 phi equal to e to the power 2 phi minus e to the power minus 2 phi by e to the power 2 phi plus e to the power minus 2 phi, and here cos alpha we write 1 as denominator. Using componendo and dividendo we get this step. Here 1 plus cos alpha, here 1 minus cos alpha. 1 plus cos alpha is 2 cos square alpha by 2, and 1 minus cos alpha equal to 2 sin square alpha by 2. 2 cancel, so remains cot square alpha by 2 right side, and in left side 2 e to the power 2 phi, here minus, here plus cancel, so remains only 2 e to the power 2 phi. Here also similarly remains 2 e to the power minus 2 phi. 2 cancel, and base same, so power in power we subtraction, and we get e to the power 4 phi equal to cot square alpha by 2. Taking square root both sides, e to the power 2 phi equal to plus minus cot alpha by 2. Therefore, first part proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.